Hello, everyone. Welcome to this presentation on adversarial search, a fundamental concept in artificial intelligence used in decision making in competitive environments. Adversarial search is widely applied in game theory, strategic planning, and AI driven gameplay, where two or more opponents compete with the opposing goals. In this lecture, we will explore how AI can make optimal decisions in adversarial settings by analyzing opponent moves, evaluating game states, and implementing intelligent strategies. Get ready to dive into the world of AI powered competitions. We'll see one by one. First, we'll see the introduction about adversarial search. This adversarial search is a search technique used in competitive environments where multiple agents, such as players, have conflicting goals. Unlike traditional search algorithms that aim to find an optimal solution in a static environment, adversarial search considers the actions of opponents, making it essential in strategic decision making. A common example of adversarial search is seen in two player games like chess, tic tac toe, and other two player games. In these games, players take turns making moves, and the outcome depends on what? Both players' decisions. The goal is not just to find a good move, but also to counter the opponent's possible moves. This is what we are doing it in chess and tic-tac. One of the key characteristics of adversarial search is that players take turns. Each player must analyze the current game state carefully before making a move, as every action influences the opponent's choices and the overall game trajectory. The outcome of an adversarial game is determined by the actions of both players. Unlike single agent problems where an optimal solution is found independently, whereas in the adversarial search requires considering the opponent's strategy and response. The primary objective of adversarial search is to maximize one's gain while minimizing the opponent's advantage. This means that players must focus not only on improving their position but also on restricting the opponent's opportunities, leading to a more competitive and strategic decision process. Best example is minimax algorithms in the that is adversarial search. The minimax algorithm used in the this adversarial search. This minimax algorithm is a fundamental decision making rule in adversarial search used to minimize the possible loss in a worst case scenario. It ensures that a player makes the best possible moves, assuming the opponent also plays optimally. The first step in the minimax algorithm is to generate a game tree up to a certain depth. This tree represents all possible moves and counter moves, allowing the algorithm to evaluate different scenarios and plan ahead. Next, what it will do, the algorithm evaluates the utility of terminal states. Each possible outcome is assigned a numerical value based on how favorable it is for given player, helping determine the best moves in a given solution. The utility values in this case or then propagated back up the tree. The maximizing player, that is white in chess, selects the highest available value, ensuring the best possible outcome for themselves. The minimizing player, example, black in chess selects the lowest value to limit the maximizing player's advantage. For example, consider a simple game tree where the max player aim to maximize their advantage while the min player tries to minimize it. By following minimax strategy, max selects a move that leads to the best worst case outcome, ensuring a favorable position. To improve efficiency, the alpha beta pruning technique is used. This optimization method eliminates branches in the game tree that do not influence the final decision, reducing the computational complexity and making the search process significantly faster. This we'll see it later. Now we'll see the comparison between the traditional search environments and adversarial search. First, if you are considering the number of agents, in a traditional search environment, there is only a single agent making decisions without competition. The agent explores the environment independently to find the best path goal. In contrast, adversarial search involves multiple agents, usually two players, who take turns making moves influencing each other decision. Next, opponents. In traditional approach, there is no opponent, meaning the agent's actions do not face interference from an external entity. It follows a straightforward problem solving approach. However, in the adversarial search, the agent competes against an opponent who actively tries to counter its moves, making the search process more complex. Next, decision making. The traditional algorithm, search algorithms, aims to find an optimal solution independently by searching through possible states and selecting the best path to reach a goal. However, in the adversarial search, requires strategic decision making where the agent must predict and respond to the opponent's possible moves to maximize its chances of winning. Next, predictability. Traditional search is deterministic, meaning every action leads to a predictable outcome. We can able to predict it. The search space is well defined in this traditional approach, and there are no unexpected changes. In the adversarial search, non-determinism arises because the opponent's choices introduces uncertainty. The agent cannot control the opponent's moves, making outcomes less predictable. Next, coming into the example, game example, in the traditional approach, you see, the traditional search is used in problems like path finding, example, finding the shortest route on a map, and puzzle solving, example, solving the 8 puzzle problem. In adversarial search, examples include chess, tic-tac-toe, and go, where players compete by making optimal moves while considering their opponent's strategy. And if you are considering the search types, in the traditional approach, search type, the traditional search focuses on finding a sequence of actions that lead to a goal, such as navigating a maze or solving a Rubik's cube types. Adversarial search, on the other hand, focuses on finding the best strategy to counter the opponent, ensuring the best possible outcome in the competitive scenario. Coming into the complexity of both searches, the traditional search generally has lower complexity because it operates in a static, well defined environment. The search process is straightforward and does not change dynamically. Adversarial search is more complex in this case because it involves multiple decision makers requiring strategic analysis and deeper searches to anticipate opponent moves. And coming into the planning type, in traditional search, planning is static and predefined. The agent can compute the entire path in advance and follow it without deviations. In adversarial search, planning is dynamic, requiring constant adjustments based on the opponent's actions. Players must continuously adapt to new game states. And evaluation. Traditional search algorithms evaluate states using predefined heuristics, the values. Heuristic means what? The values, such as the shortest path to the goal. In adversarial search, evaluation is more complex, requiring minimax or alpha beta pruning to assess not just one's own advantage, but also the opponent's possible responses, making decisions more strategic. And if you are coming to the example for the strategy, that is traditional algorithms. Common algorithms in traditional search include BFS, breadth first search, DFS, depth first search, EA star search, and uniform cost search, etc., which explore both, explores paths based on predefined rules. In adversarial search, algorithms like minimax, alpha beta pruning, and Monte Carlo tree search, MCTS, we can call it as MCTS, are used to make strategic decisions against opponents considering multiple future possibilities. So these are all the difference between traditional search environments and adversarial search. Number of agents used, opponents, decision making, predictability, game example we have seen, search type, complexity, planning type, evaluation, and the examples of traditional approaches are BFS, DFS, A star search, uniform cost search, etc. Here we are taking the example minimax algorithm, alpha beta pruning, and Monte Carlo search. Hope everyone understood the concepts of adversarial search. It is mainly used for competitive environment, that is game playing. So the remaining things we'll discuss in the next lecture. Thank you.